Hello everyone. Today we're going to be talking about parent graph transformations. Now we talked about transformations with the quadratics. These are things that change the graph, and we need to recognize what each transformation looks like algebraically, what it does in the equation, and graphically, what it does to the graph. Like I said, we've already talked about these. We've talked about them with quadratics, but the rules for transformations with quadratics still hold true for all the parent functions. Let's do a little review. What does a negative in front do to the equation? Well, a negative in front flips the equation or reflects it over the x-axis. So here's a parent graph, x cubed. If I put a negative in front of it, it flips it and gives us the new graph, the blue graph, negative x cubed. So negative in front reflects it over the x-axis or flips it. What about a number in front? If the number in front is greater than 1, it's a vertical stretch. And remember, by stretching something vertically, we make it skinnier, narrower. If the number in front is less than 1, it's a vertical shrink. It makes it wider. If you take something and push it down, it widens out. So for example, I did in black just an absolute value. Its parent graph is a V. If I put a 3 in front of it, that makes it skinnier. It stretches it vertically. If I put a 1/4, that's less than 1, it widens it out. It shrinks it. What about if we add or subtract inside with x? Adding or subtracting a number inside parentheses with x moves the function left or right, opposite of the sign. So my parent function this time, I used square root of x. It's got a dot and then it goes out like that. If I put x minus 3, that moves it right 3. With x in this case means inside the square root with x. X plus 2 square root moves it left 2. So it's opposite the sign. Left is plus, right is minus. How about outside, not with x? If you go outside, no parentheses, it moves it up or down in the same direction of the sign. So this time my parent graph is x squared. If I do x squared plus 2, it moved it up 2. X squared minus 3, moved it down 3. So those are my transformations. So let's practice this. It says sketch the parent function, identify transformations, graph the function, and list the domain and range. So we have a lot to do here. The first thing I need to do is I need to recognize that this parent function is y equals x squared. So y equals x squared. And I'm just going to sketch a graph of that. It looks like this. It's a parabola that opens up and has a vertex on the origin. Okay, it's not exact. I'm not trying to get an exact graph, I'm just sketching it. Identify the transformations. Well, what transformations happened here? The 2 was a vertical stretch by 2. So that's going to make it narrower. The x plus 1, or x minus 1, will move it right 1 because it's inside, so it's opposite the sign. And the plus 3 on the outside will move it up 3. So the easiest thing to do here is to take your vertex, move it right 1 and up 3. On a quiz or test, I'm going to look to see that your vertex is in the right space. And then narrower. It's kind of hard to exactly sketch narrower. So just recognize that it's going to be narrower. It's going to be stretched. Again, this is a sketch. It's not an exact graph. You don't have to find exact points on there. List the domain and range. Well, this is a parabola. Parabolas go forever to the left and forever to the right. That means the domain is all real numbers. How about the range? We read range from bottom to top. So what's the bottom of my new graph? The bottom is at 3. And it touches 3, so I'm going to put a bracket. How far up does the new graph go? It goes up forever, so infinity. So there's the parent graph, the transformations listed, the transformations sketched, and then the domain and the range. Let's try another one. What's the parent graph here? In this case, it's the cube root of x. So you've got to know what the cube root of x looks like. Cube root of x looks like this. Kind of like a sideways cubic. The big thing is it goes through 0, 0. Not an exact graph, but a sketch of the graph. Now let's list the transformations. This is less than 1, so it's a vertical shrink. by 1/3. That makes it wider. This goes left 4 because it's inside with x opposite of the sign. And this goes up 3. So I'm going to take the point that I know, 0, 0, and I'm going to move it left 4 and up 3. Now how do I make it wider? Well, it's kind of hard to draw exactly, so I'm just going to kind of draw it almost flatter. Let's talk about the domain and range of this guy. How far left and right does my blue graph go? It goes forever in both directions. Perfect. How about the range? How far down will this go as you go this way? It goes down forever. How far up does it go? It goes up forever. So the range is all real numbers. The domain and range of any cubed root is all real numbers. So knowing that kind of helps. Let's try another one. What's the parent graph here? Well, the parent graph is y equals 1 over x. And this is one of the more difficult ones. This has a vertical asymptote here and a horizontal asymptote here. And the graph looks like this. So what transformations have happened? Well, this is with x, so it went right 5. And this is outside of x by itself, so this went down 4. So what should I move to represent the right 5 and down 4? I'm going to move the asymptotes. The asymptote is now over here at right 5. And the other asymptote is down here at -4. And my graph still looks the same, just with a different set of asymptotes. What about the domain and the range of this guy? Well, the domain and range of this guy is a little bit confusing. Let's take a look at the blue one. How far left does it go? It goes left forever. How far right does it go? It goes right forever, so it's all real numbers. Wait a minute. Does it hit every single number between here? Are there any gaps in my left and right? Yeah. This asymptote is a gap, so I have to include that. I got to say that x cannot equal 5. Why can x not equal 5? Because it's an asymptote. How about the range? Very similar. It goes down forever and it goes up forever, so it looks like it's going to be all real numbers. But does it hit every number in there? No, you have a gap. Where's your break at? Y cannot equal -4. Let's take a look at this one, another difficult one. What's the parent graph? The parent graph is an exponential. Y equals 5 to the x. The 5 doesn't matter, it just tells you that it's exponential. Exponentials go through the point 0, 1. They have an asymptote here, and they look like this. So let's list our transformations. +2 with x moves it left 2. -6 by itself moves it down 6. So let's take the point that we know, the 0, 1, and let's move it left 2 and down 6. What else do we need to move? We need to move the asymptote. I can't move the asymptote left and right, it already goes left and right forever. But I can move it down 6. And here's my new graph. An exponential like that. Let's talk about the domain of this guy. How far left? Forever. How far right? Forever. All real numbers. How about the range? What's the bottom of my graph? Well, the bottom of the graph is -6. But it never touches -6. So what do I use to say that it gets close to -6 but never touches -6? I use a parenthesis. How high up does the new blue graph go? It goes up forever. So the domain is all real numbers, and the range is -6 to infinity, not including -6. Transformations are something that don't go away. We'll talk about transformations, domain, and range for the rest of this year. We'll talk about it in pre-calc. We'll talk about it in both calc classes. The sooner that you come to terms with the transformations, left, right, up, down, flip, shrink, and stretch, the better this year will be. If you have any questions, come talk to me. Thanks, guys.